Another application I have for you is the following. It reads, a business forms a model of its widget sales via a pricing function P of X equals 250 minus 78 times X, where X is the number of widgets sold and P of X is the sales price in dollars per widget. And we have several questions asking us about the revenue function and how we go about maximizing revenue. Okay, so let's take a look at what stands out to me as something that's really important about this question. Is one, we have a nice pricing function. It's a linear pricing function. And two, the amount of revenue you have will always be your price per unit times the number of units sold, or I can write the number of units times the price per unit, so X times P of X. And what's nice about this is, in this case, X times P of X is X times 250 minus 70 divided by 8 times X. In other words, we have a nice revenue function. And the first question we have, part A, is find R of X, and we already have it. So my suggestion would be not to simplify it and grade your part A and make sure you're good to go. Okay? But I want you to notice that if we were to clean up the revenue function, that R of X would clean up as 250 times X minus 78 X squared, which rearranged a little bit is negative 78 X squared plus 250 times X. In other words, it's quadratic in X. And since it's quadratic in X, we can use our formula for finding the vertex information, and we can say when the value of X is negative B over 2A, so in this case that's negative 250 divided by the product of 2 and negative 78, which gives us a positive value of 250 divided by 140 divided by 8. If I do a little algebra work on this, I could certainly leave my answer in this manner, or I could choose to reduce it. 2000 divided by 140 would reduce to 100 over 7. So kind of pick your battles there. You may not wish to reduce it. But this is the value X that will help us obtain the maximum revenue. So let's go ahead and put this guy here in part B, because it says find the number X that will maximize the revenue. Now when X is 100 divided by 7, our understanding of quadratic functions is that the maximum revenue itself is the revenue function evaluated at 100 divided by 7. So let's take a moment and write that out. Substituting in 100 divided by 7 for X, so we'd have negative 78 100 divided by 7 quantity squared plus 250 times 100 divided by 7. And guys, with the calc pad appearing to us a lot of times in these problems, you certainly could just put your maximum revenue in unsimplified, or you could simplify. But if I caution you, if you choose to simplify to any form, like 12,500 over 7 or taking it to a decimal, if you take things to decimals, make sure first of all that the problem doesn't say anything about prohibiting decimals, and secondly, you want to keep at least 3 significant digits beyond the decimal place as accurate for WebAssign. Okay, Now, the last question is, what's the price that goes along with selling the widgets we've identified and producing this revenue? That's two ways you could go about this. One, you could take your revenue that you already have, and revenue divided by the number of widgets that got you there should give you the price. Or you can go back to our pricing function right here and substitute in the value of x we've found that makes everything work out for us. Okay, and again, that's the x coordinate of the vertex of the revenue function. So I would substitute in 100 over 7 for x, and then that value would be my price, already indicated as in dollars per widget.